Okay, so you guys, when you open the document, should see this. Does everybody have this open? Okay, great. So, the first question we're gonna do is number 1. So last week we talked about different number systems and how our normal one is base 10, and then we talked about binary and other number systems. So how many digits does base 9 have? Well, base 10 has 10 symbols, so base 9 would have 9 symbols, right? And what would these symbols be? Does anybody know? You guys can just unmute yourself or like type in the chat or whatever. Guys, this is like the easiest question on the practice sheet. Like, okay. Yeah, okay. Some people in the chat said 0 through 8. Yeah, these symbols would be 0 through 8. Those are the 9 symbols because 0 is counted, so it's not up till 9. Okay. Okay, for the rest of the number system section, do it on your own, and then we'll review it. So I'll give you guys like 7 minutes to do that. Alright, does anybody need me to go over number 2? Okay, cool. Somebody said yes. Okay, so just like any other number system, as we learned last class, each place value is that number to the power of whatever. So we said last week, where's my mouse? Okay, we said last week regular number system base 10. The first place value is 10 to the power of 0 or 1. Second is 10 to the power of 1 or 10. Second is 10 to the power of 2, whatever, you get the idea. And then same for binary, it would be 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Okay, so similarly for hexadecimal is base 16, right? So each place value is a power of 16. So for the first place value, it would be 16 to the power of 0, which is 1, right? Second is 16 to the power of 1, which is 16. Third is a 16 power of 2, whatever. For this one, we don't need that many, so it's like fine. Okay, so the first thing you're gonna do is go to the place value that can fit your number without going over the number of symbols that place value can hold. So for hexadecimal, as we learned, it goes 0 through 9, and then once it reaches 9, it goes A through F. So what number times 16 is okay, so what's the biggest number times 16 that is less than 47? Because we're trying to find 47, right? So that would be 2, right? Because 2 times 16 is what, like 32? So we have 32, which means we have 15 left that we have to put in the next place value. I'm just gonna write that there so we don't forget. So what's 15 in hexadecimal? Well, if you look at this chart, 15 would be F. So the next place value would be F. So that's why it's 2F. Do you guys have any questions? Okay. Is anybody finished with number 3, or do you guys want more time? Okay, somebody already did it and they said 118. That's correct. Does anybody need me to go over that? I can share my screen again. Does anybody want me to go over this? This is just basically the opposite. It's converting hexadecimal to decimal instead of decimal to hexadecimal. Nobody has any questions on that? Okay, great. Now let's move on to binary numbers. So the first question I'm going to go over because we technically didn't learn it, but it's pretty self-explanatory. So a binary number is one that A cannot be answered, B is 2 questions in one, C can be answered in one of 2 possible ways, or D has 2 answers. So we know that binary is there's only 2 options, right? Like on or off, 1 or 0, true or false, whatever. That's the whole thing. So can it not be answered? It can be answered. It's not 2 questions in one. There's 2 options, but it's not combined. D is kind of misleading, but if you read C, it's the best choice. It can be answered in one of 2 possible ways, meaning there's 2 options and you can be answered with one of them. So true or false, true, or false, or whatever. So it'd be C, yeah. Somebody in the chat said it, so good job. Okay. Next thing we're gonna do together is number. Actually, no, we went all over all of this in class. So do 2, 3, and 4, and then we'll go over it. Sharing my screen. Okay, so does anybody have number 2 and wants to like give their example? I'll take multiple examples since like everybody could have a different answer. You guys can type in the chat if you don't want to unmute yourself. Okay, somebody said, what's your favorite fruit? Yeah, that's right. Any question that doesn't only have 2 answers. There's obviously more than 2 fruits. So, I don't see any other ones, so whatever. Oh, I gave you guys a lot. Does anybody have 3A? Okay, somebody said, what's your favorite color? That's also correct. There's more than 2 colors, obviously. So, that would not be a binary question. Okay, for 3A, somebody said 22. That's correct. Does anybody need me to go over that one? Okay, what about 3B? Who got 3B? Okay, somebody asked what a placeholder is in base 2. Do you mean like a place value? Like the lines I've been drawing, like these things? Okay, so you guys probably learned this in like 3rd grade, but I like to explain this just so like it makes more sense in binary. But you know, in regular counting, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever, you have different place values, right? So if you had the number like 124, this is the ones place, this is the tens place, this is the hundreds place, right? And the value for this 4 over here is 10 to the power of 0, which is 1. So 1 times 4, the value of this 4 is 4. And then, sorry, I'm writing really slow. The value of this 2 is 10 to the power of 1, which is 10 times the 2. So the value of this is actually 20. It's not just 2. And then the value of this is 10 to the power of 2, 100. So 100 times 1, which is 100. So 100 plus 20 plus 4 is 124. These are different place values. For binary, the different place values are 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so on. So if you have the number 1, 1, 0, this is 1, this is 2, this is 4. This is really messy. I'm really sorry. So in order to calculate this number, it would be 0 times 1, which is 0, 1 times 2, which is 2, 1 times 4, which is 4. And so 0 plus 2 plus 4 is 6. So the value of this number would be 6. Place value just means like the different, places the numbers can be. So yeah, do you still have a question about that, if that wasn't clear? Okay, great. I'll give you guys like maybe like a few more. So does anybody have 4A? So to convert 122 to binary. Okay, somebody said 0, 1, 1. Wait, let me just write it out. They said 0, 1, 1. 1, 1. And that's right. Does anybody want me to go over that? Yeah, I have another person who put a different answer, so I'm gonna go over this. So 122 is our number, and let's draw the different digits here. So again, this is 2 to the power of 0, which is 1. This is 2 to the power of 1, which is 2. This is 4. This is 8, 16. And it keeps going. Just like in decimal, there's an infinite number of place values because there's an infinite number of numbers, right? So, okay. So the first thing we're gonna do is try to find a number that is small enough. Try to find the biggest number that can fit your number in it. So 128 is too big, so this is gonna be 0. Like, wait, no, sorry, I said the wrong thing. The biggest number that can fit inside your number. So 64 would be the next best option. How many 64s can fit in 122? 1. So we're gonna oh wait, sorry. That's not the question. It's can 64 fit because it can only be 0 or 1. So can it fit? Yeah, so you put a 1. So 122, we took 64 out. What's 122 minus 64? 58, right? So can 32 fit 58? Yes. Can 16 fit the remainder? Yes. Wait, so that'd be what, 26? 26 minus 16, that's 10. Can 8 fit can 8 fit into 10? Yes. Can 4 fit into 2? Because 10 minus 8 is 2. No, so put a 0. Can 2 fit into 2? Yes. Can 1 fit into 0? Because this is now 0, right? No, so we put a 0. So this should be your final number. Yeah, that's how you do that. Okay, we're gonna move on to different questions because we're not gonna go through all of this in class anyway. Okay, let's do number 8. What is the largest number that can be represented with 5 bits?